Good morning. Welcome to TMMS. Today, we will learn analytical chemistry, which deals with analysis of chemical compounds. This topic is included in Class 10 ICSE syllabus. In this video, we will be looking at qualitative analysis, which involves identifying the cations present in the given compound. Here is the list of cations, that is, the positively charged ions. We have some colorless cations like potassium, sodium, calcium, magnesium, aluminium, zinc, lead, silver, and ammonium. And some colored cations like copper 2+ will be either blue or green. Ferrous will be light green. Ferric will be yellowish brown or yellowish red. Chromium is green. Cobalt is blue or pink. Nickel is green. Manganese 2+, that will be pink. The colorless cations that you see over here, they will be forming mostly white powders. Now, in order to detect the cations, either the colorless or the colored, we react the compound with sodium hydroxide or ammonium hydroxide solutions. So, why do we choose sodium hydroxide solution or ammonium hydroxide solution? Because with the given compound, sodium hydroxide and ammonium hydroxide, because of this hydroxyl group, they will form hydroxides. Now, hydroxides of all elements, all metals except potassium, sodium and ammonium, they are insoluble, which means KOH is going to be soluble, NaOH is going to be soluble, NH4OH is going to be soluble, but MgOH twice will be insoluble, so that will be precipitate. PbOH twice will be insoluble, so that will be a precipitate. AlOH thrice will be insoluble, so that will be precipitate. ZnOH twice is going to be insoluble, so that will be precipitate. How about Fe2+? Will it be soluble or insoluble? That's right, it will be insoluble. What about Fe3+? Will it be soluble or insoluble? That's right, that will be insoluble. What about copper? Copper hydroxide will be insoluble. So now that we understood all these are going to be insoluble, they differ in their solubilities in excess of NaOH solution and excess of NH4OH solution, and that is how we can detect these. Now all these, they are colorless cations. We saw in the earlier list, these are colorless cations. So all these precipitates are going to be white in color, except for this. They will be colored cations. Now from the colorless cations, potassium K1+, sodium Na1+, and calcium 2+. These ones are detected by the flame test because they will not give you the precipitates because they are going to be soluble. Calcium hydroxide is sparingly soluble, and so you will see that potassium will give non-persistent lilac flame. If it's a sodium compound, it will give persistent golden yellow flame. And if it's calcium 2+, it will give us brick red flame. On the other hand, ammonium compound with cation NH4 will not give any precipitate because all the compounds of ammonium cation, they are going to be soluble. And so ammonium radical is detected by reacting with an alkali like NaOH or KOH or CaOH twice, and it will liberate ammonia, and this is what I'm going to show you in my next video. Let us come to the other colorless cations like Ca2+, Mg2+, Zn2+, and Pb2+. When their compounds are reacted with sodium hydroxide, they form characteristic precipitates of their hydroxides, which differ in colors. Now, CaCl2 solution with NaOH solution will do double decomposition reaction, and then that will give us Ca with OH will give us CaOH twice because Ca is valency 2 plus, and so with crisscross it will give us CaOH twice plus 2 NaCl. 2 Na and 2 Cl will give us 2 NaCl. Now this one is milky white precipitate, and it is insoluble in excess of sodium hydroxide. Mg with its compound MgCl2 with NaOH both being solutions, we will have MgOH twice plus 2 Na and 2 Cl will give us 2 NaCl. This is how magnesium chloride looks like. Now we'll put it in a test tube and we'll add some water and we'll make a solution of magnesium chloride. Now magnesium chloride is a deliquescent substance. Can you see these water drops already? The drops, which is because magnesium chloride absorbs moisture from the atmosphere and dissolves in it. So they look like tiny droplets over here. This is how a deliquescent substance looks like. Look at these droplets. And this also has become moist. And this is how sodium hydroxide looks like. Now we are going to add this to water and we are going to make sodium hydroxide solution. And also understand that this also is a deliquescent substance. Means what? It is going to absorb moisture and dissolve in it. Now we have made the solution of magnesium chloride and the solution of sodium hydroxide, and I am pouring little bit of sodium hydroxide very gently. Can you see the insoluble substance that is formed? This is magnesium hydroxide that is formed. Look at our reaction. MgCl2 plus 2 NaOH gives MgOH twice, which is an insoluble substance, and plus it will give us 2 NaCl. Now I am adding excess of NaOH and let us see what happens. The precipitate is not dissolving, so it is insoluble in excess, as you can see, and this is dull white precipitate of MgOH twice, which is insoluble in excess. Now, let us take magnesium chloride solution and let us add the other hydroxide, that is ammonium hydroxide. Let us look at the reaction now. First in little and then in excess. Can you see the dull white precipitate is formed? The solution is a little dilute, that's why you can see very faint precipitate. You can see that. You can see that I'm adding in excess, and with excess of NH4OH also it is insoluble. And what is our observation? Dull white precipitate of MgOH twice, which is insoluble in excess of NH4OH. The next powder we are having here is zinc sulfate. As you can see, again Zn being colorless cation, its compound is going to be white in color. Now I have made the solution of zinc sulfate and I am adding in small quantity NaOH. Now can you see? This is how gelatinous white precipitate looks like. In small quantity, it is gelatinous white precipitate of zinc hydroxide, and if I add excess of NaOH, you can see it is dissolving. a little more in excess. There. You can see a clear solution is obtained. So what do we conclude from here? That zinc hydroxide is soluble in excess of NaOH. Now here we are with another test tube with zinc sulfate solution. And to this I'm going to add ammonium hydroxide solution, first little and then in excess. But sometimes that little also becomes too much. Here you can see this, and now a little extra I will add. This is gelatinous white precipitate. It will dissolve almost immediately. That's gelatinous white precipitate. And you can see it's becoming clearer solution. I'll add a little extra. And now you can see. A little extra I will add. There. So what do we conclude? That with Zn2 plus, that is in zinc sulfate, ammonium hydroxide solution gave a gelatinous white precipitate and it dissolved in excess. Now we come to lead nitrate. Lead nitrate again is white crystalline powder. So after dissolving lead nitrate, it becomes a clear colorless solution, and I'm adding NaOH, that is sodium hydroxide, first in little. Do you know what kind of precipitate it will get? Yes, it gives chalky white precipitate. Can you see that? This is chalky white precipitate. And let us add excess of sodium hydroxide. You can see it's become less chalky. We'll need to add some more sodium hydroxide. So I'm going to take a little bit of this lead hydroxide in another test tube, and then I'm going to add excess of sodium hydroxide. So here we continue with lead hydroxide and we will add excess of NaOH. There. Can you see it has dissolved in excess of sodium hydroxide? So what do we conclude? That Pb2 plus compound will give chalky white precipitate with sodium hydroxide, and that will be dissolving in excess of sodium hydroxide. Let us take another test tube, and in this we are going to add ammonium hydroxide. First little. There. Chalky white precipitate, and if we add excess, it will be insoluble. So you can see that the intensity of that white has not become lighter, it has remained the same. So that is what we have with ammonium hydroxide, chalky white precipitate with Pb2 plus, which will be insoluble in excess. Let us sum it up with our colorless cation. With sodium hydroxide solution, calcium 2 plus will give us CaOH twice, which is milky white precipitate, which is insoluble in excess of sodium hydroxide solution. But with ammonium hydroxide, it gives us no precipitate because we have ammonium hydroxide solution is a weak alkali. It does not have enough concentration of hydroxide ions to precipitate Ca2 plus. Let us come to Mg2 plus. Mg2 plus, we took MgCl2 and we added sodium hydroxide and we got magnesium hydroxide and 2 NaCl magnesium hydroxide being dull white precipitate, which was insoluble in excess of sodium hydroxide solution, and ammonium hydroxide solution gave with MgCl2 MgOH twice plus 2 NH4Cl, and this again was dull white precipitate which was insoluble in excess of NH4OH solution. Then we came to Zn2 plus, where we took ZnSO4, we made it into aqueous solution, we added 2 NaOH first in little, that is ZnOH twice we were able to see, which was gelatinous white precipitate, and we had Na2SO4 formed, and this was soluble in excess of sodium hydroxide because ZnOH twice is an amphoteric compound, and that will dissolve in sodium hydroxide forming sodium zincate. Then we came to ammonium hydroxide with zinc sulfate solution, and here again we had ZnOH twice formed. So 2 NH4 with SO4 gave us NH4 twice SO4. Zinc hydroxide again was gelatinous white precipitate which was soluble in excess, and that is because ZnOH twice forms with excess of ammonium hydroxide tetraamine zinc 2 sulfate, and that is how we have a soluble compound formed. So gelatinous white precipitate is soluble in excess. Then we came to Pb2 plus. Pb2 plus had PbNO3 twice a compound which we made into aqueous solution. We added sodium hydroxide and we had this reaction taking place, PbOH twice, which was the chalky white precipitate which was soluble in excess of sodium hydroxide solution because again PbOH twice is an amphoteric compound, and so it is going to dissolve in excess forming sodium plumbite, which is a soluble compound. And so we come to now ammonium hydroxide with PbNO3 twice solution. We have PbOH twice, which is chalky white precipitate, and NH4NO3, 2 of them formed, and that gives us with excess of NH4OH insoluble precipitate. So now we come to the colored compounds. In our colored cations, we have Fe2 plus, Fe3 plus and Cu2 plus. We'd already seen that Fe2 plus will give us green, that is dirty green precipitate. Let us see the reaction with NaOH. FeSO4 plus 2 NaOH gives us FeOH twice plus Na2SO4, and with NH4OH you will have FeOH twice plus NH4 twice SO4. Now FeCl3 will be FeCl3 plus 3 NaOH will give us FeOH thrice plus 3 NaCl, and FeCl3 plus 3 NH4OH will give us FeOH thrice, which is a precipitate, and then we will have 3 NH4Cl. Cu2 plus, again we will have double decomposition here. CuOH twice we will get here, and Na2 with SO4 will give us Na2SO4, and here CuSO4 plus 2 NH4OH gives us CuOH twice plus NH4 twice SO4. Now let us look at ferrous sulfate powder. This is how it looks like. It is light green in color. Now we'll make a solution of this and we will test again with sodium hydroxide and ammonium hydroxide. Now this is ferrous sulfate. It is light green color solution, and I'm adding little of sodium hydroxide solution, and can you see, this is how we get dirty green precipitate. Look at the color. And now I'll add excess of NaOH, and it does not dissolve. I'll add a little extra. You will see that the precipitate remains the same. So it is dirty green precipitate which is insoluble in excess. Now we have another test tube with ferrous sulfate. As you can see, light green it is. And now I'm adding ammonium hydroxide. First in little. Can you see that dirty green precipitate? And if I add excess, The solubility does not change. It remains insoluble in excess. We come to Fe3+, and here we have FeCl3. You can see the chunks of FeCl3. Now this is highly deliquescent substance, and so within no time it is going to absorb moisture from the atmosphere and dissolve in it. Let us see how we make the solution of it. As you can see, FeCl3, it has already dissolved in the atmospheric moisture. Can you see this? You can see the glistening droplets of FeCl3. You can see it has already stuck to the paper. It has already dissolved. Now I'm adding in that ferric chloride little water, and so we will get yellowish brown liquid. So here we have FeCl3 solution, and we are going to add sodium hydroxide first in little quantity and then in excess. You saw that reddish brown precipitate, and now in excess you will see that it is insoluble in excess. And now we have another test tube, and in this we will add ammonium hydroxide. First little and then in excess. You can see the precipitate that we got. Now earlier precipitate was a little lighter in color because my sodium hydroxide was very dilute. Now we come to copper sulfate. So we have a Cu2+, which is a colored cation. Most of the salts of Cu2+ are blue and sometimes they are green. And here you can see copper sulfate, which is CuSO4.5H2O. And you can also see this particular part has become whitish. That's because this is an efflorescent substance, and when it loses the moisture to the atmosphere, it becomes white anhydrous. Can you see this is matte finish over here? I'll just zoom in so that you will be able to see it better. There. You can see the matte finish of it, and it has become anhydrous CuSO4, that is copper sulfate. Now here we have a test tube with copper sulfate solution. I have dissolved it in water and I'm adding NaOH, sodium hydroxide first little. Can you see pale blue precipitate of copper hydroxide is formed? And I'm adding excess of NaOH, and you will see that it is insoluble in excess. Can you see that? Now here I have another test tube which has copper sulfate solution, and I'm adding ammonium hydroxide first in little. You can see it has formed pale blue precipitate. Can you see that? And in excess, if I add NH4OH, you will see that the whole precipitate is dissolved and it has formed inky blue solution. Look at that. This is because tetramine copper 2 sulfate is formed, which is a soluble compound. Characteristic of it is the inky blue or deep blue color. So let us look at our reactions once again and the precipitates, the colors of them. Fe2 plus with NaOH gave FeOH twice, which is dirty green, insoluble in excess of NaOH. And with ammonium hydroxide, again we had FeOH twice, which was dirty green precipitate, which was insoluble in excess of ammonium hydroxide. Fe3 plus, we had FeOH thrice formed, which was a precipitate of reddish brown color, which was insoluble in excess. And with NH4OH, FeOH thrice, which was again reddish brown precipitate which was insoluble in excess. Cu2 plus, we saw that it was blue crystalline salt, and then we added water and made blue colored solution that gave pale blue precipitate of CuOH twice with NaOH, which was insoluble in excess of NaOH, but with NH4OH we had CuOH twice, which was pale blue precipitate, but it was soluble in excess, forming inky blue or deep blue solution of tetramine copper 2 sulfate. So you see, with sodium hydroxide we have zinc and lead, Zn2 plus and Pb2 plus, giving us soluble precipitate, and for ammonium hydroxide we saw zinc 2 plus and copper 2 plus. They are giving us soluble precipitate. Here we had soluble precipitate because ZnOH twice and PbOH twice, they were amphoteric hydroxides, and that is why they gave us in excess sodium zincate and sodium plumbide, which was soluble compound. And with ammonium hydroxide, ZnOH twice and CuOH twice dissolved in excess of ammonium hydroxide, forming tetraamine zinc 2 sulfate and here copper 2 sulfate. This was colorless solution and this was deep or inky blue solution. And so that finishes our detection of cations. I hope you have understood how analytical chemistry uses sodium hydroxide and ammonium hydroxide solutions to detect the cations because of the characteristic colors of the precipitate and their solubilities in excess of sodium hydroxide or ammonium hydroxide. So I hope you have understood this particular part of analytical chemistry, and we will be able to answer the questions based on this a little later in my other video. Hope you have enjoyed the video. Thank you for watching.